Welcome everybody. Ohm's Law is all about quantifying electricity. How do we assign values? How do we measure the different aspects of electricity? First of all, electricity is a kinetic energy because the electrons are moving throughout the wire. The electrons are negatively charged, and each electron has a measured charge of negative 1.6 times 10 to the negative 19 coulombs, capital C. We will not really be working with the number of coulombs as we see, but it is interesting to see that the electricity, that charge, can be measured. Another thing to say about when electrons move, if you have a battery-powered system, the electron is not entering the wire from the battery, and an individual electron is not traveling all the way through the wire back to the battery. What happens is that electron is pushed into the wire a little bit, and it bumps into a neighboring electron, which starts to move, which bumps into the next neighboring electron, which starts to move, and it bump. So what we have is more of a vibration of an electron rather than an actual traveling of a distance. So the next thing that we can measure is the potential difference. This is the potential energy that an electron has. This is the push on the electrons. It is based on the fact that electrons don't like each other and they repel each other. And this push, this potential energy, is provided by the battery, a chemical potential energy in this case. And this potential difference, this push on the electron, is measured in volts. And 1 volt is 1 joule of energy per coulomb. So 1 volt equals 1 J per C. And a joule is the metric way to measure energy. Calories would be the non-metric way to measure joule energy, or BTUs, British thermal units. But a joule is how we quantify the amount of energy, the amount of kinetic energy in this case, per charge. Once these electrons get moving, they create current in the wire, and this amount of current is measured in amperes or amps. And 1 amp, 1 amperage of flow, is 1 coulomb per second. So 1 amp is 1 coulomb per second. How many electrons are flowing? How much charge is flowing per second? Then you get the resistance to the flow of electrons. This is resistance. For example, going through a toaster. The heating elements of a toaster do not allow electricity to travel very easily, and we get, a good way to think about it is we get a lot of friction. It's hard for that electron to move through, and so the electricity then turns into heat energy. If you have something with very low resistance, like a copper wire, the wire doesn't heat up and most of the electricity reaches the end. Resistance is measured in ohms, and we use the Greek letter ohm to represent an ohm. I think that's the name of the Greek letter. But 1 ohm of resistance will allow 1 volt to push through 1 amp of current. So 1 ohm is kind of the gate guard that will allow 1 volt from the battery to push 1 amp of current. So 1 ohm equals 1 volt per amp. Now, putting all of these variables and measurements together, we get Ohm's Law, where Ohm's Law, the amount of current is directly related to the amount of voltage, and the amount of current is inversely related to the amount of resistance. So I equals V over R, where I is the current measured in amps, V is the voltage, the potential energy, the potential difference measured in volts, and R is the resistance measured in ohms. This does fit nicely into a cheater's triangle pyramid, where I and R are on the bottom and V is on the top.